What if the most lethal weapon was invisible to the naked eye? Picture a threat that silently infiltrates societies, causing mass destruction without a single explosion. This invisible menace is not a figment of science fiction, but a grim reality. Bioweapons, engineered from biological agents, they carry the potential for widespread devastation, their impact seeping deep into the fabric of humanity. Bioweapons have been a silent player in warfare throughout history, and their potential for devastation continues to loom. Bioweapons, they are not a new phenomenon. They've been around since the dawn of warfare, lurking in the shadows of history, evolving alongside human ingenuity. Our ancestors, though limited by their understanding of the world, recognized the power of nature and used it as a tool for conflict. Poisonous plants and venomous creatures were their first bioweapons, crude yet effective. With time, humanity discovered the devastating potential of disease. In the darkness of the Middle Ages, the bubonic plague, or the Black Death, was catapulted over fortress walls, turning cities into graveyards. Moving forward to the colonial era, we find a chilling example in the deliberate spread of smallpox-infected blankets to Native American populations, a grim reminder of the lethal power of infectious diseases. In the 20th century, the face of bioweapons changed. Science, which holds the power to heal and protect, was harnessed for destruction. The world bore witness to the horrifying potential of engineered pathogens, as seen in the anthrax attacks that shook the United States in the wake of the September 11th terrorist attacks. As our scientific understanding has advanced, so too has the complexity and potential harm of these biological agents. From simple poisons to genetically engineered superbugs, the evolution of bioweapons is a sobering testament to the dual nature of scientific progress, capable of both saving and destroying lives. The true terror of bioweapons lies in their scientific sophistication. Bioweapons are not just a product of malevolent intent, but are also a testament to the incredible advances in biological sciences. At the heart of these weapons lies genetic engineering, a technique that allows scientists to alter the fundamental building blocks of life itself. Imagine a pathogen, a microscopic organism that can cause disease. Now imagine being able to tweak its DNA, making it more virulent, more resistant to medicines, or even capable of targeting specific ethnic groups. That's the power genetic engineering holds, and that's why it's a cornerstone in the creation of bioweapons. But this scientific prowess doesn't come without its ethical dilemmas. The same techniques that can create a deadly bioweapon can also be used to cure genetic diseases or increase crop yields. This is the dual-use nature of biotechnology. It can heal or harm, feed or famine. This duality presents a significant challenge for researchers and policymakers alike. How do we encourage the beneficial uses of these technologies while preventing their misuse? The balance is precarious and the stakes are incredibly high. In the wrong hands, the tools of genetic engineering could be used not for healing, but for harm. The fallout could be catastrophic, with the potential to cause suffering and death on an unprecedented scale. The very tools that promise to revolutionize medicine could also be weaponized to cause unprecedented harm. How do we protect ourselves against such an invisible and potent threat? Across the globe, nations have taken steps to prevent the proliferation of bioweapons. A cornerstone of this global response is the Biological Weapons Convention, a treaty that unequivocally prohibits the development, production, and stockpiling of these deadly agents. But treaties alone are not enough. Recognizing this, countries have embarked on initiatives to improve detection and response capabilities. These include the development of advanced surveillance systems to quickly identify potential biological threats, and the establishment of rapid response teams equipped to contain and neutralize such threats. Moreover, there's a push for stronger international cooperation. After all, bioweapons do not respect national boundaries. Sharing information, resources, and expertise can greatly enhance our collective ability to combat the menace of bioweaponry. Despite these preventative measures, the threat of bioweapons remains, necessitating vigilance, preparedness, and international cooperation. Bioweapons, unveiling the invisible threat. We've journeyed through time, from ancient warfare to modern biotechnology, shedding light on the chilling reality of biological weapons. We've explored the science that makes these threats possible and the ethical dilemmas they pose. Global efforts are in place to counteract this threat, but the dual-use nature of biotechnology calls for increased vigilance and international cooperation. Understanding is our first line of defense. We must face this invisible threat head-on, for the stakes are too high to ignore.